The electromagnetic spectrum. Light comes in various wavelengths, and we can't see them all. It's kind of like with sound. There are sounds we can hear, but there's also sounds above what we can hear, frequencies above what we can hear. But dogs can hear them. They're still there. We just can't hear them. There's also those are called ultrasonic sounds. There's also infrasonic sounds, sounds below what we can hear. Um, uh, there's also wavelengths of light that we can't see. There's light waves above frequencies that we can see and below frequencies, but it's all the same stuff. Um, the way I do it in my class is we always do these mnemonics, and I always start with the highest frequency, highest energy stuff. Those will be gamma rays, and I always start with the Hulk here. The story behind the Hulk, if you're not a comic book fan, um, David Banner or Bruce Banner, depending on which version that you watch, we had an accidental overdose of gamma radiation that turned him into the Hulk. And always remember the Hulk is high energy, high frequency, wavelength. The Hulk obviously has a lot of energy. And then we have Superman. I always imagine the Hulk grabbing a hold of Superman by the neck and kind of choking him a little bit. Superman, he also has X-ray vision. And so X-rays would be the next highest energy on our list. So we'd have gamma rays. I'm sorry, we're going backwards here, but that's all right. We'll get back to it. We'd have gamma rays as the highest energy. We'd have X-rays as the second highest energy. And then I have Superman is squeezing. You see his hand right there. He's got a little fist. He's squeezing some sunblock for some reason. You have to imagine this sunblock is in his fist right there. And as he squeezes the sunblock, we use the sunblock to block out solar radiation, things that give us sunburns. So we're going to use that associated with ultraviolet rays. Ultraviolet rays are high energy. They're not as high energy as gamma or X-rays, but they still can hurt us. They can give us cancer and sunburn. And so the sunblock that Superman carries around with him all the time, and he's squeezing that sunblock, that's going to be UV. So we have gamma rays as the highest, X-rays is the next highest, and then UV would be the third highest on our list. In our classroom, we always put these lists at the back of the classroom. And I imagine Superman squeezing that UV. He's got super strength, and so he instantly squeezes and just sprays out of the bottle onto a light bulb that I have at the back of the classroom. Now, imagine that UV ray, the sunblock just dripping off of the light bulb. Maybe the light bulb is on, and there can be it's burning that UV a little bit. I mean, the burning the sunblock, and you smell the coconuts and the tropical scents that they usually put in sunblocks. And so with mnemonics, they all need to be connected together, and the more senses you can, if you can add smell to that, it solidifies it more in your memory. Of course, the light bulb is going to represent visible light. And then out of the visible light, all of these things will be higher frequency than we can see. Visible light we can see, and then the rest of these are going to be lower frequency than we can see. Out of the visible light, we have this red extension cord. That's going to represent infrared. Infrared is heat, all right? We have infrared goggles that we can see, like body heat. The military uses them at nighttime to be able, your body has 98.6 degrees. You can't see that wavelength with your eyesight, but you are glowing in the infrared. And with special goggles, you can shift that spectrum that you can't see into visible light. And of course, they have the infrared goggles. Take that cord and wind it up in the microwave. Maybe we're doing science experiments in the science class. We're going to see if we can cut on the microwave and get my light bulb to light up. So we're going to wind the cord up into the microwave. And of course, microwave represents microwave radiation. Would be the next one as we go down. And then because I like to listen to the radio when I do science experiments in the class, I'm going to put an old school radio on top of my microwave. And this is going to represent radio waves. And this is all the electromagnetic spectrum right here. This is the high energy down here with the Hulk. The radio, I think, is being relaxing music, so it's low energy. It's long wavelengths. If you go to the beach and take your radio with you, the waves at the beach, they come in, and one might hit the shore, and then about 15, 20 seconds later, another wave might, but there's a long distance between those waves. So these are the gentle, very elongated, low frequency, low energy wavelengths. The question up here is asking you to list them in order with from the longest wave. So we'd actually go backwards in this case, where we'd start with radio, and then the radio sitting on top of the microwave, and then we have inside the microwave is our red cord, which is infrared, and then we have our visible light, and then we have the sunblock that gets sprayed onto our light bulb and is dripping off of it. And Superman is the one who is squeezing that sunblock, and of course that's X-ray. And then of course the Hulk would be the final. He's fighting with Superman, so gamma ray would be the final one that we'd have up there. One last thing while I'm up here, Roy G. Biv, of course, the colors red, orange, yellow, green, blue, indigo, and violet would be inside of my light bulb here, because that's all these together make white light or visible light. But from high to low energy here, the red on the Roy G. Biv would be down here next to the infrared, and the violet would be up here next to ultraviolet. So red is lower energy than violet is, because it'd go Roy G. Biv with the violet and then over here. So in terms of the color of lights, red is lower energy and violet is higher energy, because this is the higher energy side over here that we can't see. And red would be next to the infrared and all the lower energy stuff that we can't see, which goes back to stars again, where red are the lowest energy or coolest temperature stars, but the blues and the violets, those are the higher energy stars. They're going to be a hotter temperature as well.